Hey guys, this is Ben from Chegg Tutors here, and today we're going to cover the statistics concept of type 1 and type 2 errors. So in this video, we're going to define what type 1 and type 2 errors are, we're going to go over an example, and then we're going to answer some common questions about type 1 and type 2 errors that you might encounter in your course. So let's get started. So type 1 and type 2 errors, as their names might imply, are errors that you can make in data analysis during hypothesis testing. So these errors can occur during any kind of hypothesis testing really, whether it be like two-sample mean, chi-square, you name it, whatever comes up in your course. So what exactly are they? First, before we consider the errors, let's look at the normal cases, or what we normally expect from our hypothesis tests when we get information from them. So let's look at the chart over here on the left. So I'm going to walk you through on how to read it. On the top row over here, we have what's called the truth. So these categories are going to be what's true in the natural world. So what's actually right in nature. So we have two columns, the no hypothesis is true column and the no hypothesis is false column. So these two columns are going to determine whether or not your no hypothesis is actually true, regardless of what your report or what your analysis tells you. On the other hand, on the left over here, we have the your findings section. So, as you may have guessed, the your findings section is going to be what your hypothesis test returns you. So it's whether your hypothesis test tells you that your no hypothesis is true or your no hypothesis is false. So pretty simple, right? So as you may have figured out by now, there are two general conditions. Your findings and the truth can either match or they can disagree. So let's look at the matching conditions first, because they're what we normally consider normal from what hypothesis test gives us back. So the two matching conditions are here. Let's circle them in blue. Yeah, there you go. Okay, so the first one is going to be when your findings or your hypothesis test reports that your no hypothesis is true, and in nature, it is true. It is in fact true. So you made a correct judgment that the no hypothesis was true. And the other correct judgment you can make is that your no hypothesis is false, and in nature, it is in fact false. So pretty simple so far, right? So these are the matching conditions. This is what we expect from a good hypothesis test, in which we trust the results that it returns to us and we expect it to be correct in the actual world. Okay, so now let's look at type 1 and type 2 errors. So as you can tell from the chart, a type 1 error is when you, in your finding, you report your no hypothesis as being false, but in nature, it's actually true, and vice versa for a type 2 error. So looking at this chart, this can be pretty abstract. So let's look at an example. Let's say that you are testing a new drug, and that you're testing it to see if it lowers the blood pressure of patients. So let's say this is a two-sample design, and you give group A a placebo, and then you measure the blood pressure and you take the mean, and then you give group B your drug, and then you also measure their blood pressure and take the mean. So this mean blood pressure A over here represents the mean blood pressure of the placebo takers, and the mean blood pressure B over here represents the mean blood pressure of the drug takers. So a quick review on hypotheses writing. So for your no hypothesis, that would just be the default, or what we would expect if our drug didn't work. So what we would expect is that the blood pressures would be equal. We would expect that the drug has no effect on the blood pressure. On the other hand, our alternative hypothesis, in this case, would be that the mean blood pressure of group A, or the placebo takers, would be greater than the mean blood pressure of group B, the drug takers. So our alternative hypothesis is that our drug works as we intended, and it lowers the blood pressure of group B. So let's look at our correct scenarios again. So the first correct scenario would say that our findings reported that our null hypothesis was true, so we said in our report, based on our hypothesis testing, that there was no difference in the blood pressures. And, as it turns out, in nature, the drug actually doesn't work. There is no difference in blood pressures. So, once again, this space right here says that we say that our drug doesn't work, and it actually doesn't work in nature. Our other blue circle over here, our other correct square over here, would mean that we report that our drug does work. In other words, our null hypothesis is false. So our drug does work, and in nature, our drug actually works. So we report that it works, and it actually works. Great. So now we can get it onto the market. So what happens when these statistical analyses give us incorrect results? Well, the first one that we talked about is a type 1 error over here. So as a more concrete example, a type 1 error in this case of our drug would mean that we say that our drug works. So that's us saying our findings say that the null hypothesis is false. We say the drug works. But in nature, it actually doesn't. So we report to the board of higher ups that, hey, our drug works, but it actually doesn't in the general population. So this would be what a type 1 error looks like. Once again, it's when you say your null hypothesis is false, but it's actually true in nature. Now, let's see what a type 2 error looks like in this case. So in the context of our current problem, a type 2 error would be that we say our drug doesn't work. In other words, we say our null hypothesis is true, but it turns out that our drug actually does work. It turns out that the truth is that the null hypothesis is false. So here would be like us missing out on like a big drug discovery. We just like write it off as a drug that doesn't work, we discard it, we move on to the next project, when it actually does work, and our hypothesis test analysis just failed us. So yeah, so this is what type 1 and type 2 errors look like. These symbols next to them are how we denote the probabilities associated with these kinds of errors. So this alpha over here, next to the type 1 error, may look familiar to you. It also stands for the significance level that you run your test at. So as you may recall, the lower your significance level, the stronger your test is. And the more certain you are when you say that your null hypothesis is indeed incorrect. So this alpha is the same thing as that significance level, which is the same thing as the probability of a type 1 error. On the other hand, this beta represents the value of the probability of us conducting a type 2 error in our analysis. So now that we understand what a type 1 and a type 2 error are, let's address the common question that comes up in a lot of courses of which one is more serious. Well, the short answer is that there is no concrete answer that you can always use for this type of problem, because it depends on a lot of things. It depends on the type of problem you're trying to answer with your hypothesis test, and it also depends on what viewpoint you're taking. So let's once again go back to our drug example. So looking at our type 1 error, what would be like the immediate consequences? Well, recall that our type 1 error means that, once again, we say our null hypothesis is false, we say our drug works when it actually doesn't. So who stands to take disadvantages from this? Well, the most immediate ones who would suffer from this incorrect report would be the patients. The patients who take this new drug that gets approved because of our hypothesis test analysis, they would expect a decrease in blood pressure when it actually has no effect whatsoever in nature. So that's pretty bad. So from the perspective of the patients, that'd be pretty bad. They'd just be taking a useless pill and wasting their time and money on the drug. On the other hand, let's look at the type 2 error. So who loses out in this deal? Well, let's recall what this means. A type 2 error is when we report that the null hypothesis is true, so we're going to report that our drug actually doesn't work. But in truth, in nature, it actually does work. So recall that this is the scenario in which I said that the drug company would be missing out on like a big discovery, and they basically shelve the drug instead of proceeding into market because, hey, this hypothesis says it doesn't work when it actually does. So in this case, the ones who would be missing out are the drug company. They can't make money, or they make a lot less money. They lost out on a money-making opportunity. So, if you ask the common populace which type of error is more like consequential in this case, well, the general answer would probably be the type 1 error in this case. But once again, that isn't always the case. For example, if you asked which type of error is more consequential from the perspective of, let's say, an investor in the drug discovery company, hey, maybe he would say that the type 2 error is more significant. Maybe he would say that, you know, the prospect of losing money hurts him more than the prospect of giving people a drug that doesn't work. So yeah, it all depends on context. If you're asked to answer this type of problem, as long as you can justify your answer appropriately with the type of always address who would suffer from whatever type of error you're encountering, and always remember to refer to the context of the problem. And your answer should be decent. So remember that there isn't always like a straightforward, you don't just memorize, oh, it's always type 1 or it's always type 2. It depends on the context, and you're going to have to justify your answer based on the type of study that you're talking about. Okay, yeah. So that's pretty much it. So to review, a type 1 error is when in our hypothesis test we come to the conclusion that our null hypothesis is false, when actually in nature that null hypothesis is true. And a type 2 error is the exact opposite. It's when in our assessment we conclude that the null hypothesis is true, when in nature it's actually false. So remember that these two can have different effects on different populations, and that their severity is relative to the problem at hand and the audience. Alright, so I hope that type 1 and type 2 errors are clearer to you now, and I hope that this problem made sense.